Cloud, that's what I need. There we go. Okay, let's start. Rant done. Here we go. Okay, so module 2, you guys technically you don't have to have already done lab 0 yet. So you could be as far behind as not even done the syllabus quiz. But hopefully at this point, everyone's done the syllabus quiz. I need a nod from you. I got the one person that I can see the face of nodding, so that means all of y'all did it. I'm so proud of you. The next step would be to get lab 0 done and quiz 0 done. Both of those. Nigis doesn't count if you did it and you're not showing your face, because you're just not counted in the big group. You don't have to show your face if you don't want to, but if you don't show your face, I get full privilege to shit on not showing your face. So glad all of y'all did the syllabus, because it really isn't that hard. So if you, it's good that you did it, Nigis. Also, if you need to correct my name, you gotta say that. Like that, you don't need to show your face for it, but I will do correct names if you want me to. But yeah, lab 0, quiz 0, we covered that last week. So if you need that, oh yes, you might want to get on the person. You might want to get on the Zoom call for this link. But if you don't want to get on there, you can send me a DM on Slack and I'll send it to you. But I got the YouTube playlist set up for our recordings. So the recording I'm making now will go there. You can see all my preferences. I play Genshin. I'm a weeb. Okay. Here we go. Someone else joined. Oh, it's you. I did literally just say to get on it. Okay. So here's the link. Everyone, hello to the person that I'm actually looking at, Olivia. She's now joining you online, sharing her screen. We're in the same room. It's great. This is peak high flex. This is peak high flex. Okay. So there's the link to the YouTube playlist. Go there for recordings. Recording for module 1 / module 2. Hey, we got another phase. And see, we still have 100% syllabus completion rate. See, it's easy. Okay, so yes, there's that. So good for lab 0, quiz 0. I'm not going to be going over that this presentation, but if you have any questions about that after this presentation, just let me know and we can talk about whatever you want to go back to. But if you don't have any questions, but you still want something covering it, you can go to that and that should help. Theoretically, also the lectures and Zybooks will also help with that too. But we are covering lab 1 and quiz 1 today. And just the dates are here, so get those all done by Sunday and get quiz 1 done by Tuesday. But without further ado, let us jump into some coding. Okay, lab 1. Oh wait, no, okay. So, I didn't have, this is so much easier when it was back to back, because I just left the stuff open, but now I've closed everything, so I gotta go open it. So lab 1, there's a lot of documentation about it on Zybooks itself. So if you go here to lab 1, there's all this stuff. And most of the things that I'm about to talk about, I've just copied and pasted Stoy to my PowerPoint. I haven't read what goes on here though, so that's going to be different from what I talk about, but I'm going to talk about my own experience with it and usage. So first off, get line. That is how you get a lot of user input. Is there a correlation to that in Java? You have next. Is next line a thing in Java? Scanner.
Yeah.
Next line. Okay, so then scanner next line. That's what it's equivalent to. Yeah, easy. So getLine is equivalent to that, but getLine has some interesting functionality that we'll talk about. So here we go. Let's delete all the stuff from before. Let's leave the return 0. So super blank, completely empty. I'm not even doing the includes yet because I want you to see me have the errors in the includes and dealing with them. So from Zybooks, I'm just going to copy and paste this example. And you'll see that by itself doesn't work. You'll notice that a lot of times if you just try to copy and paste stuff without anything else, it probably won't work. And really, you shouldn't be copying and pasting too often, but just this kind of thing, it doesn't work. When you run into stuff like this, and it's not included, most of the time it's really easy to find out what you need to include to use it. So for string, anything when it's underlined like that because you don't have access to it, but you know that you should have access to it, you just need to include something. Just go to Google, paste it, C++. First thing you find, string specifically, it doesn't have any examples here because string itself is very, like you can use strings for things. So just go to a function. So I'm gonna do find. I think that one I know has been working. Where's find? I'm gonna control F to find. There it is. So find has an example of strings being used, and in their example on this website, that has the include that it's supposed to be. So just copy and paste that from here. Put it here. And then we know CN from last time. So that one you should know at the top of your heart, or will soon know because you're going to repeat it like 10 billion times. And then using namespace, I can spell std. There we go. So get that all set up, and now this works. The way getLine itself works is the first thing that it takes as input is a input stream. Now, right now, we only have the standard input. Sooner or later, we'll get to file inputs, but just CN for now. And then an actual string that it's going to store what it gets from CN inside. It doesn't return the string. It actually returns a true or false value, telling you whether or not it's gone to the end of the input stream. But we'll cover that more when we get to file streams, because with the C input stream, there is no end. There is not an end to that, but files have an end, and that's where that becomes useful, returning true or false. But for now, that's not a thing. And then if we see out this, just see out input, and then I'm going to do endo and run this. It'll get, once it loads, this is all gonna be got. So it grabs all that stuff. One thing that getLine does have that isn't shown here, and as another thing they'll talk about when we talk about file streams. I know I'm saying a lot of stuff will be important when we get to file streams, but it's true, and we're covering getLine now, so I want to introduce that to you guys so that when we see it in the future, you'll not be shocked and be like, I thought it was used this one way. Well, it's used multiple ways. So right here, we've got this two different setups, two different parameters for getLine. One of them is the one we just used, which is just an input stream and a string. The other one is very similar with an input stream and a string, but then this delimiter character. So the delimiter character is saying, instead of going to the end of a line, go to this specific character. So my favorite example, I don't know why it's been my favorite example today, but we're doing it, is Z. So with Z, if I ran this, I could say this is included, Z, this is not. So now with that, if I press enter for that, it's only going to get everything before the Z. Now you might be tempted to use this on the lab because you know we're dealing with, well, you might not know, but spoiler alert, you're dealing with commas and you have to do like, is there enough commas or not? No. I'd recommend not trying to find a way to use this setup with Lab 1, just because I personally don't know how I would use it with Lab 1. So I couldn't easily recommend you a way to do it. If you find a way to do it, that's great. As long as you get the grade on Zybooks, that's the important part. But I'm not recommending it. We'll talk about some future stuff when we get near the end of the lab. Okay, but that's getLine. I'm going to close Steam, actually Steam and Discord, because I'm notorious for getting Discord messages while I'm TAing lab. See, it's just gotta move all of it out of the way. We'll get there. Olivia gets a first-hand view on me having to move shit out of the way to get this done. Okay. What was I saying? Yes. So talked about getLine. Next is set with justification and then getting the correct values from Zybooks for this kind of thing. So y'all know how cout works. You put the thing in, it prints the thing out. We've done that a million times. So I'm going to change this to just equal hello. So if you see out at hello, it would put it there. That's great. Actually, I shouldn't even have run that. That's super straightforward. Well, look, it's taking forever to print out hello, there it is. Did I still? No, I don't know. Okay. And if we put it inside of these bars, I want it like this to do what I want it to do. Yes. There we go. No more. If we put it inside these bars, you can see all the space that it takes up. This I do actually want to show you. That's what I want to do first. So there you go. It's inside those bars. Set width is a function that you call inside of this whole cout thing. So like as another element of cout, like if you wanted to output a number and then a string, you would do one less than input. Replace this one with set width. And you input a number, and this number, it's mad at me for some reason. Oh, yes, it's mad at me because it's undefined, but I know it's something that exists. If it's undefined and I know it's something that exists, I just need to include something. I did not mean to be that. I did not mean to accidentally forget that this is what I was supposed to do. But there you go. IO manipulation. So that's the include we need in order to access this. So copy that. There you go. Now we have set width. There we go. So if we run this, and here actually I want to do a smaller number because I think with a smaller number it's more obvious. If we run this with say input is, I'm going to do 7. So we run this with set width of 7. It makes the whole width of it 7 characters. I'll zoom in for you, Olivia, so you can see it there. So 1, 2, 3, 4, 5, 6, 7, and it adds spaces to make it the right length. So that's what set width does. Now, let's say you wanted it on the left side instead of the right. Justification works the same way. Justification is just the words left or right inside these little bracket things here. So if we run this, it'd make it on the left. And see, look, it's still 7 characters. I know, I'm magic. It's so great. Thank you. One little misconception I see some people make when they're trying to do justification, because they know, oh, and there's also right justification. But with this specific setup, right justification, I could do like 2 quick runs right after another. Right justification and not right justification look the exact same. I know I went by that really quickly, but it was just to point out the fact that they look the exact same. Now, if we put this, I want that. There we go. If we put this after, it does not look the same. So make sure you put it in the right order. So this did hello and then 7 spaces. Actually, 1, 2, 3, 4, 5, 6. So it made the next string and cout encountered be 7 spaces. So it actually made this be 7 spaces. That's what it specifically did. Almost lied to you there for a second. So make sure you put set width in the correct place you want it to be. The correct place you want it to be for this lab, not going to tell you straight out, but we tell you that this needs to be 23. So you get to use some big brain thinking skills to figure that out. If you do have questions, I'll be happy to answer them. But the idea is, even after like understanding that concept of how set width works, you can try it out and test it a little bit and eventually get to this result. Okay. So left justification, right justification, set width. Oh yes, we tell you what the value should be. So don't go trying to like mess around with values. Right here. Yes. So we tell you that the title is right justified with a set width of 33, and that the column 1 is with a set width of 20, and that column 2 is with a set width of 23. And then hopefully you can see based off the columns if they're left or right justification. This one's only a little weird because it's centered. I mean, it looks centered, but it is right justified with that set width of 33. The only potentially weird part is this little dash in the middle. That's not a part of column 1 or column 2. That's its own thing. So that doesn't have a width. There's a width for this, a column, and then a width for this. You'll see it once you start messing with Zybooks and submit something. If you've got like weird values, you'll be good. Okay, so that's that. That's that. Oh, scrolling. Move out of the way. Oh my gosh, I covered up the chat. Ah, I'm so sorry. Okay, is it right on default? Yes, I think I covered that. Can you put it in the middle? I don't think there's a middle justification. Let me put this up top so I don't lose that like I did last time. I'm very sorry about that again. I'd want to say center, input. Oh, I'm messing everything up. Center, set width, 30. No, center's not a thing, but we can go look in IO manipulation real quick, actually. I wanted to back out. IO manip, there we go. Is left justification not a part of that? C++ left justify. So set width is not connected to left and right. Whoops. This is just an IO string. I don't see a center. I'm not seeing one. There's internal. What the hell is internal? The input is padded to the field width by inserting field characters at specific points. N is -77. What the heck? I have no idea what internal is, but that's not, I've never used internal, but that does not look like centered. So I'm gonna go with no. But you could try messing around with that, but these looks like the only justifications there are. Is the left right internal. And pad of the field width, inserting. Oh, here we go. So for numerical values between the sign and a numerical base and the number magnitude, for non-numerical values is just equivalent to right. So internal is definitely not a center at all. It's specific to numbers. Okay, so that was a good tangent. Back to what we're doing. So that's that. Okay, next up, Stoy. Stoy in Java was very similar to integer.parseInt. I think that's a concept. And it looks like, so let's make this 5, sure. We can get rid of this, let's get rid of that. That. Input, there we go. So Stoy looks like that. And then you could do like +3 or something, or +4 in there. And so now it's working like an integer. Adding it together, if we ran this, it would output 9. I can do math. 9, easy. Woo. One thing that I do want to point out, just because I've had the question probably like 2 times now in my whole career, so it's not an option, but it is a thing. Stoy, string to int, does not change the data type of input. It just, it's a function that has parameter of a string and a return type of an int. So input is still, like if I want to do something with input down here, that wouldn't be valid because input is still a string. So it does not convert it to a string. Another thing, this one just comes more to debugging. And this one's actually common. So especially in this lab, it's obvious when I do it like here, actually, in this lab, you're going to be given bad values. Where is it? Like right here. So this is a bad value, this is a bad value, bad value. Here's an actual good value. You're theoretically, the number in a good value, you find the comma, and then you take the substring of you skip the space, and everything after that space, you get that as a substring, and that should be an integer. And if everything works out correctly, all the stuff after the space will be a valid integer, and you can do what you're supposed to do. However, since there's invalid stuff, if you just did that right off the bat, you could somehow, you find the comma, one after the space, get all this input. This could all be stored in your input. And if you tried to do story with that, I'm going to get rid of that, it wouldn't be valid. So it's not an error right here because it's a runtime error. And so here we go. We get this unhandled exception. I'm going to close that. This invalid argument exception. If you're using stoy and you get an invalid argument exception on the stoy, the line where stoy is run, the first thing I'm going to ask you to do is put a cout statement right before you use stoy and output whatever you're putting into stoy. This is super helpful. Like I've even caught myself where stoy wasn't working and I do this. If you then run this, as soon as it crashes, everything was still running. So it'll output the last thing that you tried to put into stoy. And that's how you can figure out if what you put into a stoy was a number or not. And so obviously in this case, since I hard coded what input was and I tried to put it in a stoy, I knew what was going to happen. But when you're using your code and it's just in a while loop or in a whatever loop, and you're not actually seeing the direct values, this is like super important to figure out. So a cout right there will help with debugging a lot. My ear, this is getting attacked by a mask, headphones, just glasses. It's having a good time. Okay, so that's stoy. I don't think there's anything extra with stoy, but I am keeping it because the next thing we'll cover is try catch. Try catch. So let's say it was going to be an exception, but you wanted to be able to have an exception there because you wanted to be able to do something if there was an exception. What you can use is try catch. I'm fairly certain try catch is something that's in Java. I'm fairly certain I also know that the implementation is also almost the exact same. So try catch, and then in the catch you put something. In our case, to find the something, if you know an error is going to occur and like the error's already happened before, the error message will have what the error type is. So I can just copy and paste this std invalid argument, put it there, and you have to give it a variable name. So I'm just going to call it ERR. We also don't need the std : because we're using namespace std. So if we do that, hello, here we go. Error caught. There we go. So this is how you can intentionally, or not even intentionally, but know that that error could potentially happen and deal with it. So this right here does not have to be a cout statement. It can be anything you want, but that's just one way to deal with it. And that is a way you could handle this lab. So you could, in fact, make it so you do try to get this information, and if stoy gives you an error, then that's an issue, and you catch that and do something with that information. I'm trying to think of an issue where I think that'd actually be pretty good. There might be some way that doesn't work. I haven't tested it. If you come across an issue with that, I'd be happy to help you figure it out. But that's a good way to do that. Okay, so that's everything with the lab. I feel like there was something else I wanted to talk about with the lab, but I can't put my finger on it. Do any of you guys have any questions about what we just talked about? We got an I'm good from Olivia, muted so you guys can't hear that. Okay, awesome. Well, oh, I saw the chat this time. Is it okay if we don't use try? Yeah, no, I don't care how you solve the lab, Xander. Xander asked if it's okay if we, you can see it. I forget this, whatever. Yeah, you don't have to use try catch blocks. For every lab, unless we explicitly tell you not to use something, you can use whatever you want. That goes the other way. I don't think there's a lab we explicitly tell you to use something. Of course, there might be like a certain problem where it can really only be solved one way, but however you want to do it, that's totally up to you. Oh, yes, I know. Strings. So I didn't cover it there. In programming 1, Some of you might not have taken programming 1 if you like skipped it with APs or something. That's totally fine. But we assume that you know the stuff from programming 1. And in programming 1, you use Java. And I know for a fact at some point you had to use like substring and maybe find. I know for a fact substring. I don't know about find. But C++ has a direct correlation to substring. The function's called substring. So if you Google string, substring, C++, right there, it's the first result for me, and there's probably like a 9 out of 10 chance it's because Google knows me and I love this website. But it's right there, and it goes through like all of its uses, and it's a great example right here. So if you're like, how do I use substring? Right there. If you don't know what this is saying, I can tell you it's start at the third index, so 0, 1, 2, 3, so start at T, and go 5 characters. So 1, 2, 3, 4, 5. Yes, the third character is the entire thing. So that's what that does here. So I think that's a little different from Java. I think in Java it was the first index and the last index, but very similar concept. And then also the find function. I don't know if that was a thing in Java, but it even shows it right here. Find is almost like it's perfect for what we're trying to do. So yeah, using the find function would probably be a good idea to find a comma. Hint, hint, nudge, nudge. Okay. So that's that. Okay, so I'm assuming there's still no questions for that. I'm gonna move on. Okay, quizzes. Like usual, I will go over the study guide, and then I think I had like one extra thing I wanted to cover that wasn't on the study guide. And like I said, I don't have it open because I'm living my best life. Scroll down. I'm not going to show you the actual quiz. Here we go. Okay, so why do we write classes? We write classes because in C++, classes allow us to organize our information so that if we can think of something as an object, we can write it as a class and associate variables and functions with that object or with objects of that type. So why do we write classes? To organize information. Now, when you talk about encapsulation in C++, classes and also structs, we'll cover structs in a little bit, but structs are more for things that you access the information out of. We'll talk more about that when we get to like a linked list, because those have nodes, and a node's entire existence is supposed to be for storing one small piece of information. So that's what structs are usually for. But in C++ encapsulation, to implement encapsulation, we use classes and structs. What encapsulation is the act of organizing information in objects. So in other languages, they might not have the concept of classes, but most object-oriented languages, and especially in C, oh, she left before I could say goodbye. But yes, especially in C languages, they're going to have a class almost guaranteed. So yeah, encapsulation is the concept of putting things inside of objects and storing variables and stuff. In C++, we use classes to do that. Why do we do it? Because object-oriented programming is a very efficient way to write code and also very readable. So that's why we do that. Construction, what does a constructor look like? How do we write one? So you've seen constructors before. You've done constructors in Java. Just going to cover it real quick in here. I'm only going to do the header information. Whew, hiccups. Okay, so in my testing class, look at that, default constructor, int x, another constructor, and there's another one. And you could add more parameters. You could change the parameter types. You can do whatever you want. But these are all constructors. So what does a constructor look like? How do we write one? There you go. This is the default constructor. What is a default constructor? The default constructor is what's called for an object when another constructor isn't. So let's get rid of all of that. So let's say we did testing temp. Let's say we did that. Oh, I need to include. So make sure you include the H files and you do it in quotes. So that's different from what we've done before, testing.h. So that is different. When it's your own file, you do it like that. So there we go. Temp is constructed with the default constructor. So like in here, I'll write it in here. If we did this, that should be legal. I'm just gonna run it. If it's not legal, I'll figure it out. There we go. So outputted 10. So this constructor, this default constructor, all it did was see out 10. So if I created more, if I just kept creating more of these, it would keep see outing 10. Another way to write default constructors, this is very important because I think this is different from Java. You might have a similar thing in Java, is you can write parameters and then do equals something. So let's do equal 20. So now what this means is that if you call something without a parameter, without this here, it will call this function and just replace x with 20. So there's now two ways to call this function. You can call it, this is going to be an error. You could call it as like testing var1 equals testing, or testing var2 equals testing 10. And both of these, and actually here, I'm going to comment this out for a second. Both of these will call this one because it has a default value, so it doesn't need to exist. So it's not a super important concept, but it's important in the fact that like this allows you to do some things where if you want this to be the default value, if they don't care what it is, that's what you can do. So if the user doesn't care what this value is, you can set that. It also makes it so like if you know you want to create like humans and you want to have the person who's using it be able to enter whatever they want, but if you want default values, then you can do like have the name be, I don't know, Norman or something, and you could set those things. And so that way you only have to write one constructor. So this way you really only have to write, so like let's private variable int num, sure. You'd only have to write num equals x, and you wouldn't have to define two things because you wouldn't have to define that and also, I commented out. I could just, no, fuck it, it's too late. You wouldn't have to do that and num equals 20. So that thing that I had before would do both of these concepts. However, when you do it like this, there is an issue where you can only have one default constructor. So this is a default constructor. Another way you can use this, using this doesn't have to mean you have a default constructor because you could do like character h, comma, int x. And so in this case, they have to put this character for the first parameter, but the second parameter is optional. And this is not a default constructor anymore because there are parameters. But going back to the default constructor, you can't have both of these exist because you can only have one default constructor. The error doesn't occur here though. This is not where the error occurs. And you could actually even go here and write it. Oh, and this is how you write it. It does look a little different. You don't do int x equals whatever you said equals to. I think I did 10, maybe 20. You don't do that. You just do in testing x. So you just say that. So this isn't an error because it's matching the one here. And you do whatever you want there. We could see out x, sure. But here's where the error occurs, right here. So if you hover over temp, it says, hey, testing has more than one default constructor. And so that you're not allowed to have that. That is an error. So that's an issue with that. But that's a couple ways to write a default constructor. Do you need a default constructor? I just showed you that you can't have more than one default constructor, but you don't need to write a default constructor. And that's because of the implicit constructor. Oh, no, that's a lie. You don't need to write a default constructor. The answer flat out is no. There is some rules about default constructors though, and in constructors in general, and it comes with this implicitly declared constructor. So if I had no constructors, I'm going to control X this. If I didn't have anything, this is constructed with the default constructor. This is the implicitly declared default constructor. I haven't written anything, but it sets all the private member variable values to their default value. So with an int, I think we learned last time that there is no default value for int, so it is like it's unknown. So that is like, you can also technically do this. So if you did that, then that's the default value. But the implicitly declared constructor it just sets these to their default values and doesn't do anything special with them. If at any point you write a constructor, so let's say you just do this. If all you had was this testing char y, now you've told this code, you've told C++, you're handling all constructors because you're allowed to not have a default constructor. That is legal. But so in this case, you're saying there is no default constructor, only the ones I've declared. So now this is an error because there's no default constructor for this class. So I've seen a lot of people fall into this and they're like, hey, when I was originally writing this, it wasn't giving me an error because they didn't write a constructor yet. But as soon as you wrote one, you have all this other code that exists. Now you get an error. So just make sure you understand that. As soon as you write one constructor, that is saying you're in charge of all constructors. So if you don't have a default one, that's an error. So that's the implicitly declared constructor. That's if you don't have any, it'll make you a default constructor. But if you have one, then that no longer exists, and you don't need a default constructor. How many constructors can an object have? As many as you want. The only limitation is on the default constructor, you can only have one, but for how many constructors can you have, that's as many as you want. Okay. What is the purpose of an accessor? What is the purpose of a mutator? So accessors and mutators, I think you've heard of get and set. Yes, I'm going to assume yes. So getters and setters, those are just if you have member variables, like let's say num, you would do int get num and void set num. It looks something like this. If you wanted to define them, you could easily define them in the header, and that would be return num. I'm gonna put it all in one line because I think that reads easier. And then here it would be num equals x. There you go. So get num is an accessor. You're getting access to that information. Set num is a mutator. You're changing information. So the purpose is to define the level of access you have to member variables. So we're about to talk about the different levels of accessibility. There's private and public, but creating getters and setters allows you to mix, like if you want something to be private, but you want them still to be able to read the value, if you want it to be read-only, you could have it private, but then have a getter. So they could read it outside, but not set it. And we'll go into that in a little bit when we talk about public and private. Can you explain protected? Well, we're not covering protected yet. Protected talks about inheritance. So if you know private and public already, if you don't have a question about that, then then protected is if you have an object that inherits, like let's say class test2, is it extends? I think it's please be extends. Testing. Extends might be Java. Yeah, it's definitely not on the quiz. I want to show you though. Inheritance C++. What's the keyword? I just don't know the keyword. class shape. It's just a colon. I'm good. Here we go. Colon. What do you mean you forgot it? Oh, Nick, for being late. How dare you? It's okay. The only real reason I shit on you is because you're not showing your camera. Unlike the one person who doesn't need to show her camera because she's in person with me. Okay. So with inheritance, if you already understand public-private, protected allows you to access the variables in something that inherits it, but like this private variable, this private num, you would not be able to access it here. So like let's do void foo. If we use this object, which we'll cover in a second, we have access to get num, set num, but not num. But if we did protected char y, sure, then we would have access to it here. So you don't need to know it yet, but understand that the protected, what is that? There's a word that it's in the thing. The protected level of accessibility has to do with inheritance, and we're not covering that yet. Okay. Oh, and Nick, here, I'll post it again. This is recorded, and I have the playlist already set up. It doesn't have this video yet, obviously, because it's being made, but the video will be posted there, so you're totally fine. You'll be able to see all the stuff that we covered earlier. Okay, so that's protected. Covering that up. Covering that up, do not need it. Okay. Cool, so that's accessors and mutators. That was just the get and set stuff we talked about, but that'll come up again when we talk about here. So what is the invoking object? And that is connected to what is the this keyword. When we start talking about the this keyword, my words get more jumbled than they already are, because I cannot use the word this unless it's in the context with this keyword, or else everything gets confusing. And in my mind, I start saying fuck this, but I don't say it out loud because, again, this keyword. Okay. So first thing, what is the invoking object? Let's get this to not be in there. See, I can't use the word this. It's cheating. Here we go. Testing, default, colon, testing, int x. I think that's all I needed. That's fine. I'm going to delete this. Okay, so there we go. The invoking object. Anytime, like, so we have, or object-oriented programming, objects have variables associated with them, but they also have functions. So if we call one of these functions associated with this object, we are calling this function on this object. So get num, actually I'm gonna do set num. Set num 12, that's fine. So we are calling this function on this object. This object right here, temp, in this case, is the invoking object. So to answer the question of what is an invoking object, it's an object that's called, when it's calling a function, the object is the invoking object. Not all functions need an object. You could make void add just out here, chilling, not doing anything. It's called add, doesn't actually add anything. That's fine. You can call add. There's no invoking object. But when you're dealing with invoking objects, you get access to a fun little special thing. That is the this keyword. So let's go to my implementation of setnum. Let's make it so it's actually big. Here we go. So in working with the invoking objects, you get access to the this keyword. Right now, in our current setup, right here, if I did this arrow, what I put here would be the same thing as what I put here, because the this keyword is implicit, just like std::: is implicit. However, with the same thing with std::: where technically you could define something as cout, you can define something as num. So if I did int num equals 0, now there's two separate nums in two different scopes. So if I highlight this num, you'll see that this other num is highlighted. But if I highlight this num, it's not. And we'll see if I commented this out before, I could highlight this and it would highlight all those other nums. That's not important. Okay. But so if I did this right here, if I did int num equals 0, we can still get access to the private num up here, to the num associated with the invoking object by doing this dash arrow. So now you'll see, since I've done this dash arrow, that's saying, hey, I'm talking about the num specifically associated with this object, with the invoking object, and that is here. So that's the this keyword. If you wanted to call inside of this function, if you wanted to call another function, or if you wanted to call void change stuff, this function does like a lot of weird things. There's nothing there, but just trust me, it does weird things. Sure, it doesn't actually do anything. I'm just saying that. In order to call this, you could just do change stuff, but calling this would be the equivalent as writing that. And in the same way, you could do character change stuff. Not even that. There you go. I think, would this be mad at you? Yes, this is mad at you because it's thinking you're talking about this. So I know that seems really redundant and like, why would they have that? The whole point is that C++ isn't hindering you in any way. If you wanted to create a variable called num while you had a member variable called num inside of a member function, you're allowed to do that. C++ is all about allowing you to do it. Most of the time, you won't actually do it. So most of the time, you do not need this implicit this object here. However, the one thing I have seen when some people are writing set mutator functions, sometimes instead of doing num equals x, I've seen this multiple times. So if you ever do it, don't feel bad at all. Gladly help you fix it. If someone did this, sometimes when they mean it, they accidentally do this because they know that like, hey, num's an int, so I'm going to do int num equals x. And like, oh, I guess this works. There's no error here. There is no error there. The thing that will happen though is that once you've called this in your code, later down the line, the num member variable won't have been changed. So it can be a hard error to spot because you don't realize that this is an error because it's a logical error. It's not a compile time error. It's human error. So sometimes people do what I just showed right here. And that's where what the examples all I just talked about are important. It's not when you're trying to use num, it's when you aren't trying to do this. So a big complaint about C++ is it allows you to do a lot of things it really shouldn't allow you to do, but it's not hindering you. That's a big concept. Okay, not there yet. So that's the invoking object, that's the this keyword. We've talked about different levels of accessibility. I guess we only talked about protected. The different levels of accessibility are private and public. Public means when you're outside of this class, so like right here, if I make an object of this class temp and I do temp dot, it has access to all the things that were public. It does not have access to the private stuff. I could make a member variable out here that's in the public section, and now I can do temp dot, and you'll see I have access to y, and I can set, I can change, I can get the value of, I can do whatever to y now because it's public. Private means that you can only access it when you're inside of member functions or inside the class definition. So private is more like only I should be able to access this. And the key point where this becomes important is if you make a C library that gets compiled and sent to someone else and they're not supposed to be able to change the code. They're not supposed to be able to like go inside the code like you can right now and mess with stuff. You want to dictate the access level they have to things because you don't want them accidentally going in and changing something that isn't supposed to be changed that could mess up your code later. So that's where this becomes really important when you're like, I know someone who just has this should not be able to in main change a value. That's where you'd want to put it. In this class specifically, a lot of times there's never going to be a situation where that happens. And so you could just put everything in public and it wouldn't affect too much. But it's very good practice to put things in private that should be private. And it also really helps you as a coder so you don't actually do something stupid. So really just getting a good habit of figuring out like what level of access you think something should have, give that to it. But you could just have everything be public. Okay, last couple of ones. What accessibility does a class have by default? What about a struct? So a class by default has private levels of accessibility. So what I have right here would be the same as doing that, because classes by default are private. So if you don't put an accessibility above it, it's private. So if I had gotten rid of this public, now everything's private. And if everything's private, that means these, yes, you don't have to type private. It'll by default put everything private. I do because I like to be explicit. I think in C++ being explicit has helped me a lot. I know one thing I don't do explicitly is I don't do this keyword very often. So I guess I'm a hypocrite if I say I'm explicit everywhere. But in some cases, I do like to just do it. But yeah, you don't need the private. But you shouldn't make everything private, because if you've got like these constructors private, then you don't even have access to the constructor. So that's not a thing. It even tells it right here that this is inaccessible. So you do want things to be public, and so you probably will have to explicitly put public somewhere. And then another thing is that you actually don't even need private there. Like I said, it's the same thing as not putting it there, but you can put another level of accessibility somewhere else. So you could do like int z, and then you could do public character s, put in the character z, and this character, there we go. So you can swap around. Like, you don't have to have only one of each. You can have multiple. However you want to organize your code, that's up to you. When it comes to structures, structures. Specifically with what accessibility do they have as default? It's the opposite as classes. So structures by default have public inheritance, and have public accessibility. So structures and classes are very similar. I bet if we Googled, we could probably find something else. Struct versus class, C++. There might be some other difference. Oh, no, even this might be a lie, because this is on Stack Exchange, so it's just somewhat equivalent. But yeah, the only difference between class and struct in C++ is that structs have a public member bases and classes have default private members and bases. So that's the big thing between classes and structs, is that default level of inheritance. So if right here, if I change this word from a class to a struct, I wouldn't have to change anything else. But now if I went here, I could do temp dot, and I'd have access to num. So that's the difference there. Okay, last but certainly not least, how are classes broken down in separate files? What parts of a class go in which file? You'll notice I've taken some liberties on this. That's because in real life, in existence, again, C++ isn't trying to limit you. So you can put anything anywhere. I've seen people put entire big projects inside of main. It hurts my eyes to see, but I support whatever you can do to get your stuff to work. I will say that people who do that, if they come to me for help, it takes longer, and I've had to actually deny one person because it was taking too long, and I told them that I just couldn't read their code, so this wasn't going to work. But if everything works for you and you're getting everything running and you don't need anyone's help and you're just living your best life, I don't care what you do. For this class, however, when we talk even right here in the quiz and in the quiz study guide, we ask you like how things are broken down. We're going to ask you how are they formally broken down? Like, what are you supposed to do? What you're supposed to do is write all of the function prototypes in the header. This is what creates, I'm going to change it to class. This is what creates the class definition. So what you're supposed to do is have the class definition in the header file, and then you're supposed to implement the member functions in the CPP file. That is what's supposed to happen. The reason for this, there is a reason why this was designed this way, is because it's twofold. The first one is readability. A header file should be short and sweet and just list all the functions you have access to. Maybe every once in a while you put a comment in if you think something isn't clear and saying, hey, constructor assigns num to x. Like if that wasn't clear, though this is pretty clear since there's only the one integer there and the one integer there, it should be pretty straightforward. But if it's not obvious, or maybe you could, if it does something completely weird, just says constructor couts x. Like if it's something that isn't obvious, you could put a comment there too. But yeah, headers are supposed to be readable because this allows you to like hop around and figure out what you have access to and what level of accessibility they are, so where they have access outside of this class. And then the CPP file might be more of a clusterfuck where you don't know what's happening and there's algorithms left and right. So like another good example is if you implemented a sorting algorithm, in here you could just write sorting, and people are like, oh yeah, that's a sorting algorithm. Like you put a comment here, it's like, oh, this is binary sort. But the actual algorithm for binary sort is just a mess sometimes, and so the code doesn't look anything like it. Like it's not obvious to read. You'd have to go line by line, but this is super readable, so you know what you have access to. So that's the first reason. The second reason is because in C++, every time you change a file, that file has to be every time you change a file and try to compile, it has to be recompiled. So like right now, if let's get this without errors. I don't think I have an error right now. Right now, this is compiling and I've changed every file, so it's recompiling every file. And it takes a hot second. If I ran it again, it would run really fast. Again, super fast. It doesn't have to recompile anything. Now, in actuality, the first one wasn't really slow. I think my computer just has this weird thing. But the general idea still stands. When you change a file, it has to be recompiled. Now, this hashtag include stuff at the top, what that does is it copies and pastes the contents of this file into here. So testing.h, every time I change it, it changes every other file that hashtag includes testing.h. But theoretically, if you do stuff correctly, your function prototypes, your class definition shouldn't change very much. You should be able to know going in what these should be. You don't have to know. You can change them. You're allowed to change them. It just might take a little longer to compile. But it's usually easier to figure out what these are going to be and have them stay concrete. But your CPP file where you actually define stuff, that might change a lot. That as you're fixing bugs, as you're running stuff, that could change a lot. Luckily, main.cpp does not hashtag include testing.cpp, and you should not do that. It only includes the header file. So that makes it so every time you change the CPP file, this testing.cpp, it only has to recompile testing.cpp. It doesn't have to recompile main or testing.h. So that's the second reason, the whole compile time issue. Obviously, that's more of an issue when you get into bigger projects, but in a bigger project, that could be a big issue. So you'd really want to make sure you're doing that properly. When I took this class, when we were doing projects, there wasn't Zybooks. We just submitted stuff. And the professor actually took points off for if you didn't have it properly organized in your H and CPP file. And I remember the first time it happened to me, I was like, wow, how dare you? My code works. But that's totally up to you. In this class, that's not a thing. And in Zybooks, sometimes the person who wrote the Zybooks problem didn't care about that, and they don't actually even give you a .h or a .cpp file. But if you do it on your own, it's a lot easier to go from multiple files and just like copy and paste them where they need to be into one. And most of the Zybook stuff is simplistic enough that that's not a super issue anyway. Starting last semester, actually, some students requested to have those files, and so we added them. And so if you want to use them, you can. If you don't want to, you just put a comment at the beginning saying not using it, and it compiles, and you're fine. If they're empty, then you get an error because it doesn't compile, but that's an easy one to fix. So yeah, that's how classes are broken down into separate files with the class definition. With the class definition in the H file, and then the implementation in the CPP. So that's everything from the study guide. And then one last little bit. I know I said the other one was the last one, but one thing I want to cover is the new keyword in Java and C++. I know the first example that comes to mind for me is like a scanner. You would do scanner input. I'm going to say in because I already have an input. Oh, no, I don't. Input equals new scanner. And then you'd write system.in or something like that. So you do something like this, and obviously these are errors because I haven't defined any of this. But in C++, the correlation of that would be no new, and then I guess technically this would be cin. But that's scanner isn't a thing, but just this is a parameter that takes something in, so I'm not going to worry about that actually. Point is, you don't use that new keyword. However, the new keyword does exist. We'll definitely talk about that later. That's a big thing in C++. And it's actually the whole reason why we teach C++ is because of the new keyword, because that talks about pointers. So a pointer Any data type can be a pointer. I'm just touching on it now just to show you how the new keyword works. You do that, and then I'm going to call it variable equals new int. Sure. Yeah, it might not be it might be the next unit. If the next unit's pointers, let's go look. If the next unit's pointers, then definitely. And we'll get to that soon. It happens quick. Pointers, references, and a dynamic member. Exactly, John. Yes. So that is the next thing that pops up. So you'll learn about this real quick. It might be lowercase I. There we go. So this is a pointer. That's where the new keyword is used. Nick, so do you know about pointers and you're asking, oh, without the new? Okay, so the new keyword allocates memory on what's called the heap. And I'm saying this now, you don't have to listen. Fox does an amazing job discussing this. I think it's great that he's like consistent with this and everyone likes, if you don't like how he explained that, that's fine. I'll be happy to explain my way, but he is very good at it by multiple people saying it. So I wouldn't get too hung up on what I'm saying here. I'm saying it's correct. It's just not a good way of explaining it. Anyways, the new keyword allocates memory on the heap that is whatever you're trying. So in this case, I did int star var equals new int. So it allocated an integer on the heap and then returned a pointer that points to what I just allocated. So that it knows how much memory to allocate on the heap just because it's allocating the memory on the heap. Integers have a set amount of memory. That's not, how does it know? Just because the integers have a certain amount. But then without the new keyword, it allocates on the stack. So it's never an issue about knowing how much is allocated. The issue with that is when the allocation happens and where it happens. When you're allocating memory on the stack, you have to know how much memory is being allocated, and it will happen in like a certain order. The whole concept of stacks is you have to keep putting things on top of another, so something in the middle can't change. On the heap, however, stuff can change because it's randomly surrounded around your computer. You can allocate more memory somewhere else and you'll be totally fine. So like I said, Fox will explain that better, but how does it know how much memory to allocate without the new keyword? It's just because variables store a certain amount of data types. So on the stack, that it does that amount and you're good. Okay, that is now everything. Any questions right at the bat? We got a head shake from Olivia, and I'm taking her as the representative of the whole class at this point, so I'm gonna get a no. With that, I am done. If you have any questions, feel free to stick around. I technically am supposed to be here till 8:10. I might, if no one's here, I might vegetate out, so I might miss. How did you do the thumbs up? I think it's like at the yeah, reactions. Wherever you see reactions. He figured it out. Okay. You can also have fun backgrounds. Oh my god. I know only Olivia is sharing her screen right now, but I'm gonna show mine off. This is my favorite background. I was using this a lot when COVID started. It's less relevant now, but honestly, I think it's still kind of relevant. It's always relevant, this is my opinion. But this is my favorite background. Okay. Oh, and you can also do video filters. Learn that at a TA meeting. I'm a cool guy. I think so. I had one that was a dog thing before, but it's lost, and I don't know. Wait, hold on. I can find this. I know where this is. Hold on. This is worth it. Where's my backup? Where's my time capsule? Yep. Clubs, grip art. Where did it say it was? Grip art, zoom background, dogs. Dogs. There we go. No, not that. Funny doggo. Yes, there we go. Move that there. This is very important. How do I add? I've done this before. I know how to add a zoom background. I'm not completely illiterate. There it is. Close. Oh my god. Cool girl Olivia rocking in the house. See you, John. I made this is a custom one completely. I made it on like a GIF thing. Giphy, I think is what it was. I'm gonna turn off my video filters, but yeah, this is also a good one. See you, Xander. Nick, you're the last digital person to leave. If Olivia wants to leave, she has to pack up, and that's a process, and no one wants to deal with that process. There, saying thank you. Yeah, so it's recording. I should stop the recording now, shouldn't I?
Hi, Nick.
Okay. Stop the recording.